Okay, hello everyone. We are at section 5.3 at this time as we're rambling through the semester here. We're into October now. October, November, half of December, so we got a ways to go. But nevertheless, section 5.3, the objectives are to add and subtract rational expressions with the same denominator. All right, much like we do when we're solving fractions with the same denominator with numbers. Now we're going to have polynomials involved. And in part B, objective B is to add and subtract rational expressions with different denominators. Okay, so let's start with our first objective here, A, adding and subtracting rational expressions with the same denominator. All right, and those are fairly easy. I hope I can say that. I'll just follow example or practice problem 1. Go by the book here. Practice problem 1, where it is written 2 over x, and that's going to be added to 7 over x. Okay, and our main objective when we're adding and subtracting fractions is to get the denominators to be the same. All right, then it's a matter of just adding the two numerators. So here, we're given the problem, and it is already the same. The denominators are already the same. So we just carry that over to the right side. And then we simply add the numerators. And here I've got 2 plus 7 is 9. So I got 9 over x. It's easy when you're doing numbers to get the denominators to be the same, but we'll be challenged a little bit with the polynomials. All right, so let's go on to example 2. And not example 2, what do they call it? Practice problem 2. So we're going to add 2 over x squared minus 1, and that's going to be plus 2 over x squared minus 1. All right, our denominators are the same, so I can carry over the x squared minus 1. And then I'm going to add the two numerators. So this is just 2x plus 2. So if I bring that over and I've got 2x plus 2, now I want to check to see, boy, if I factor this 2x plus 2 and factor the denominator, what will I have left? Okay, what will that do to the problem? So if I factor this, let's see if I can squeeze it in here. I'll scoot over a little bit. If I factor this 2x plus 2, and that means I'm going to take out a 2 and divide back what's left over. So I got 2x divided by 2 is x, and then 2 divided by 2 is positive 1. So I got 2 times x plus 1. And I'm going to bring that over here. And then I'm going to factor this difference of 2 squares. Well, I remember this is a difference of 2 squares, so I can factor that, and I'll put it underneath it. It's an easy one. If you remember that they're 2 square numbers, that's what makes it easy. And then fill it in. You have to recognize difference of 2 square problems. That's really the key. So I got minus and plus, that's always true. And then how about 1 and 1? And when I get that, what happens now? I factored both components of the numerator and denominator. So the x plus 1's cancel out. And I'm left with 2 over x minus 1. And this is our answer. All right, so we make sure we break that down and factor because we're looking for something that we can cancel the numerator and the denominators with. Okay, very good. Let's go on to practice problem 3. Okay, so here's practice problem 3, where we've got, it is saying let f of x equal 4x minus 7 over x minus 4, and g of x equals 3x minus 3 over x minus 4. Find and simplify f of x minus g of x. All right, so I have it outlined for us here where we've got f of x is this 4x minus 7 over x minus 4 minus 3 of x, no, 3x minus 3 over x minus 4. So our denominators are already the same, and now this is tricky with respect to subtracting a binomial. So let's carry over the x minus 4. That's a given, since they're already the same. And then I've got 4x minus 7 minus 3x minus 3. So I want to put this in parentheses, and maybe perhaps I can write down what I've got so far, which is the 4x minus 7. And now I'm going to distribute the negative to the binomial here. This is a negative 1, and then I'm going to distribute it to the two terms in the binomial. So that'll give me what? Negative 1 times 3x is negative 3x, and negative 1 times negative 3 is positive 3. All right, and this is what I've got thus far. And how about if we clean this up? Meaning 4x minus 3x is x, negative 7 plus 3 is negative 4, okay, and that's going to be over x minus 4, and x minus 4 over x minus 4 is 1, and that's it. So the key part here that you must remember is when you have subtraction problems, you're going to subtract that binomial. So you have to enclose it in the parentheses and distribute the negative 1 to both the terms in that binomial. And that's why I say it's helpful to enclose it in parentheses. That'll help you remember you've got to subtract both terms in that binomial. Many times students will just subtract the first term and not the second one. So I don't know what that's about totally, but you have to see that through so you get the problem correct. All right, so that was the third practice problem, and probably that might be about it for objective A, and it is. All right, let's go on to objective B, where the denominators are going to be different. Okay, here we are with adding practice problem 4. Okay, so we've got two fractions where the denominators are different, and I want to add these together. And the goal is to get the denominators to be the same. And one thing that's this is kind of cool because we can cheat a little bit here. Not that I'm condoning cheating, but you know what I mean. But I've got a means of doing this where we can take the angst out of approaching problems where the denominators are different. So in other words, I've got a 14 in the denominator and a 30, and I have no idea what common multiple they have in common. So what I like to do is I'm just going to multiply the left side by 30, top and bottom. So it's 30 over 30, which is really 1. And then I'm going to multiply the second fraction by 14. Like so, top and bottom again. All right, so let me mess that up a little bit here, and I'll bring it over here. All right, so this is what I've got so far. I haven't done anything. I just know my denominators are the same now. Isn't that correct? That is correct. So I'm going to bring over the denominators, and notice I'm not multiplying them together. I'm just going to bring over 30 times 14, just like that. And then when I look at my numerators, here I've got 30 times 3, which is 90, and I'm going to add 90 to 7 times 14. And what is that? 70, 80, 98. That's 98. Okay, then I could say what's 90 plus 98 is 188. 188. All right, so we've got that. And now I can simplify the factors here that are in this numerator and denominator. I can simplify that first. So, I don't know, what's something, you can use your calculator, of course, but I'm a freak of doing mental math or manual math, I guess you'd call it. All right, so what have I got here? I could say that 2 goes into 30 and 2 goes into 188. So 2 goes into 30 15 times, and 2 goes into 188. That's like saying, what's half of 188? Well, it's 94. All right, and I'm going to keep going. I've got another even number with the 14, and I could say 2 goes into 14 7 times, and 2 goes into 94. What's half of 94? Looks like it's, well, 45 is 90. 46 is 92, and 47, it looks like, would be my top number. 47. So now 47 is a prime number, and I'm left with 15 and 7, so I have no numbers that'll divide into 47 over 15 times 7. Okay, so I'm going to do what? I am going to, did I mess this problem up? I got 1 over 20. Oh, I looked at that example 4 again. Doggone it. I put the wrong numbers down here for 21 and 15. Oh, shoot. Well, I'll continue on. This is what I've got. It doesn't really matter. I'll do both of them for you, though. All right, so if this is, you can see I have 3 over 14 plus 7 over 30. Are we talking, I did the example then, is what we ended up with. And so when I finish this, I've got 47 on the numerator, and 15 times 7 is what? 70 plus 35 is 105. This is actually our example 4, not the practice problem 4. All right, so there's our example for practice problem 4. And if I were to do the power practice problem 4, it's 1 over 21 plus what? 4 over 15. So let's do that one at the same time. All right, and then you'll get the idea of what I did here without actually multiplying it. So over here, I'm going to multiply top and bottom by 15 over 15. And the 15 I'm going to multiply by 21 top and bottom. Okay, as I bring it over now, I've got my denominator is 15 times 21, and my numerator is going to be 15 times 1 is 15, plus 4 times 21 is 84. And 15 plus 84 is 99. 4 plus 5 is 9. 8 plus 1 is 9. Okay. And now I'll take it from here to say, well, let me figure this out. I've got 15 here and 21 and a 99 on top. Well, it looks like 3 goes into 99. 3 will go into 99 33 times. And then 3 goes into 15 5 times. Okay, so that means I'm going to have over here 5 times 21. I'm not done yet. All right, then I further break down this 33 over 5 times 21, and then I could say, well, 3 goes into 33 now 11 times, and 3 goes into 21 7 times. And 5 times 7 is 35. And now you can see I can't break that down any further, so this problem is done. And these are the problems we're doing with number values. I'm getting the denominators to be the same by working with what I've got. And now we'll go into doing the real learning with practice problem number 5. All right, this is an example of doing it with numbers. Now we're going to do the same thing, only with polynomials. Get those denominators to be the same. Okay, so here's practice problem 5. 1 over x squared plus 8x plus 15 plus 3 over x squared minus 9, and I have to add these up. Okay, the denominators are clearly different, so what I want to do is I want to factor these two denominators and then make them the same. Apply our rules for making them the same. All right, so let's see. How about this? How about I factor this left side on the denominator, and that is two binomials, x, plus, and it looks like it's going to be 5 plus 3. Okay. And now, so this is gone. And now I'm going to factor this denominator. This is a difference of two squares. And when I factor the difference of two squares, I've got x and x, minus and plus, and 3 and 3. All right, so now this is gone. So these are my two denominators. Make sure they don't run into each other where you're losing sight of what you're doing here. But this is my denominators now here. This is one of them. Let's see how I have to rewrite this anyway. And this is my second one here, and we're adding them together. Okay, this part is gone. And how about it? Now I want to get my denominators to be the same. All right, here I've got an x plus 3, and here I have an x plus 3, but I don't have an x minus 3 on this side. So I've got to multiply the left side by x minus 3, top and bottom. Okay, that's all I want to do right now. So I've got 3 components that make up the denominator now. And then on this side, I've got an x minus 3 and an x plus 3, but I need an x plus 5. So I'll multiply top and bottom by x plus 5 and x plus 5. Okay, so stop a moment, reorganize a little bit, and let's decide what I have. I have decided that I have a x minus 3 times an x plus 5, this can be written in any order, times x plus 3. This is my denominator now because they are the same. And then I've got to multiply the numerators before I add them. So here I've got x minus 3 times 1, which is x minus 3. And now I've got plus 3 times x plus 5. Well, I don't have to worry about distributing a negative because this is a plus sign. I'm just going to distribute the 3 times x plus 5. And how about if I do that? It's going to be plus 3x plus 15. There we go. I did not have to do this because what we're going to end up doing is combining our like terms in the numerator. All right, when I do that, I'm going to have x plus 3x, which is 4x, and then negative 3 plus 15 is positive 12. And that's all going to be over x minus 3, x plus 5, times x plus 3. All right, so now we're almost done. And I'm looking at that 4x plus 12, and I'm going to say, I'm going to factor that. I want to see if I can get an x minus 3 or an x plus 5 or an x plus 3 left over that will be able to cancel something out here and further reduce this. So when I factor 4x plus 12, well, I'm going to take the 4 out and divide back what's left over. 4x divided by 4 is x, and then 12 divided by 4 is 3. This is gone. This is my new factored 4x plus 12, and now you can see I've got an x plus 3 here and an x plus 3 here that cancel out. and what I'm left over with is going to be my answer. So in the numerator, I'm going to have 4, and that's going to be over x minus 3 times x plus 5. And do not multiply those together. You do not have to. Leave them separated. And there you go. It's kind of fun, actually. I think I mentioned that before. Okay, let's go on and try practice problem 6. All right, practice problem 6, as you can see, is before us. And what I want to do is I want to start this, since the denominators are different, I want to factor these two denominators. All right, so that means I'm going to take out a 2, and I'm going to have x plus 4 left over. Okay, and on the right side, remember this is subtraction as well, and then I've got x squared minus 16. Well, that's a difference of 2 squares. So that's going to give me this here, x minus 4 and x plus 4. All right, so now I'm going to work to get my denominators to be the same. So I can see I both have x plus 4s in both of the denominators, but I don't have a 2 in both of them. So let's take care of that. I need a 2 on this side, so I'm going to multiply top and bottom by 2. I'll just do it like this right now, 2 times 4, and then 2 times the x minus 4 times x plus 4. And then on the left side, it looks like we're missing a x minus 4 because I have the x plus 4. So I'm going to multiply top and bottom by x minus 4. And then x minus 4 on the top. What I do to the bottom, I have to do to the top. Okay, so I have a couple of binomials there that I have to multiply together and subtract the 8 is all that looks like. So my check, I got an x minus 4 in both of them. I've got a 2 in both of them and an x plus 4 in both of them. I multiplied the top and bottom of the number that was missing, or the expression. All right, so now I've got my denominator, which is going to be 2 times x minus 4 times x plus 4. All right, so that's taken care of. And let's take care of our numerator. All right, so this is what I've got. So this means I have to multiply this together, this x minus 4 times x plus 3. And when I do, I'm going to try it over here. I'm going to get x squared. X times x is x squared. Or I'll tell you what, I'm going to be you and do it like this. X minus 4 times x plus 3. I'm just multiplying these together. And then I'm going to have x squared. Outside is plus 3x. Inside is minus 4x. And last is negative 12. And then I'm going to go ahead and subtract the 8 here. This 2 times 4 is 8. So I'm going to subtract that 8 at the same time. Okay, and then what am I going to have left? I'm going to have x squared minus x, and then negative 12 minus 8 is minus 20. All right, here I've got my numerator over my denominator. And now, what do I have to do? Now I've got to factor this x squared minus x minus 20. Really not clear to do that down here. So I'm just gonna, because I gotta incorporate that negative 8 to it, to the rest of the trinomial here. So let's factor this numerator. Okay, and that's gonna be an easy one. We've done it many times already. And I'm going to have this is going to be x minus plus, and what are my two numbers going to be? Minus 5 plus 4 gives me that negative 1 in the middle. And I'm going to put that over 2 times x minus 4 times x plus 4. And now we're at the point where we can say, hey, what can cancel out? So I can simplify. How about the x plus 4's cancel out, become 1's, and I'm left with x minus 5 over 2 times x minus 4. And that is the solution for practice problem 6, where we're subtracting. Excellent. All right, practice problem 7. Okay, my denominators are different. I know to factor these denominators, so let's go ahead and do that. Minus and plus, and it looks like this will be 2 and 1. Negative 2 plus 1 gives me that negative 1 for the middle. Negative 2 times 1 is negative 2, and that checks out for my constant. All right, so that's gone. And this trinomial, I'm going to factor it the same way. X and x, plus and minus, and then how about 3 and 2? All right, so here are my denominators. We got to get them to be the same. So notice I have an x minus 2 already in both of them, so I can leave that alone. This one has an x plus 1, but the one on the right side doesn't have x plus 1. So I'm going to multiply top and bottom by x plus 1 and x plus 1. Okay. Then on the left side, I've got x minus 2 here, x plus 1, but I don't have the x plus 3. So I got to multiply top and bottom by x plus 3. And this one, I'll just shove it here, x plus 3. I know my denominators are the same now. And let's go ahead and then take care of our numerators. So let's see if I do it this way. I've got x plus 3, x minus 2, times x plus 1. Denominators that are the same. All right, then my numerator here. Well, I'm going to distribute the x going back. Or this is x minus 1, right? Yeah. So that is a, I got to FOIL that, in other words. So let's go ahead and do that. So this is going to give me x squared plus minus x plus 3x and minus 3. Minus now be careful here because it gets to be a little bit odd. So if I took this negative and put it with the x there, I could say negative x times x. And that would give me negative x squared. Negative x squared. All right? And then I'm going to say, what is negative x times 1? Well, that's negative x. So I took care of that in one shot. A lot of people like to do that in the two steps, but this is negative x, and I'm distributing it across to both of those terms. And this is what I get at this point here. Now I've got to combine all my like terms. And let's do that. Let's see what we can do here. I've got an x squared minus x squared, so those just go bye-bye. All right, here I've got a negative x minus x, so that's going to give me negative 2x. Negative x minus x, and then I've got a positive 3x. Okay, so I've got 3x minus 2x is 1x. So this just really becomes x. Color I have there. So I got negative x plus 3x is 2x, and 2x minus x is 1x. And then finally, I've got the negative 3. So it's x minus 3. And that's all going to be over the denominator here of x plus 3 times x minus 2 times x plus 1. And I'm looking to see, can I cancel anything out of that? And the answer is no. I did all the work I needed to do, but I don't have another x minus 3 that I can cancel it. So if I don't have it, I don't have it. Don't force it in there. Don't make anything up. That's my answer. And we're done with that problem. Okay, good. All right, let's see what we've got here. They like to throw us off by writing this out in words, but we are not afraid. We are not afraid. Let f of x equal x squared over x minus 3 and g of x equal 12 minus x over negative x plus 3. Find and simplify f of x plus g of x. All right, so that's just a matter of writing out f of x, which is x squared, over x minus 3, plus g of x, which is 12 minus x over negative x plus 3. You could flip that around and write that as 3 minus x if you wanted to, but we want to get these to be the same again. All right, so here I've got x minus 3, and this is negative x plus 3. So let's see, what can I do here? I'm going to factor this right side here. And one of two things I could do. I could factor this as it is. That means if I take out a negative 1, and divide back what's left over, I'm going to get negative x divided by negative 1 is x, and 3 divided by negative 1 is negative 3. There we go. So that means I'm multiplying top and bottom by negative 1. Did I do that right? Yeah, because I've got an x minus 3 here and an x minus 3 here. This side does not have the negative 1, but this side does. Okay, and I'm wondering, I think I did the wrong side. I think it's over here. So let's just leave this as negative 1 times x minus 3. And let's go over here and multiply both sides by negative 1. So this one I'm going to multiply by negative 1. Okay, now they're going to be the same. So top and bottom, negative 1. And this one I just factored for the sake of getting my denominator. So I'm not going to multiply that by negative 1. That was a mistake on my part. All right, so we've got, I factored this denominator here. It gave me negative 1 times x minus 3. Then when I compare the two denominators, these have x minus 3 already. This one had the negative 1, but this side did not. So I gave this side the negative 1 and multiplied it top and bottom. So amongst all that, what have I got? I've got a denominator of negative 1 times x minus 3. And then on the top, I've got negative x squared plus 12 minus x. Plus 12 minus x. Okay? And let's scroll down here a little bit. Need a little bit more room. now it looks like I'm going to factor that negative out again. I didn't really have to do that, but in light of it, I'm going to rewrite this to be in descending order as well, this numerator here. So let's factor that negative out of the numerator. So I'm going to factor out a negative 1. I'll do it on the right side here, negative 1. And then when I put back what's left over, I've got x squared. And then I'm going to put the x next. This is negative x divided by negative 1 is positive x. And then I've got 12 divided by negative 1 is negative 12. Okay, and that's all going to be over negative 1 times x minus 3. And what can I do at this point now? Well, I can cancel the negative 1's at this point. And then I can factor the x squared plus x minus 12. And if I factor that, I got all this area over here, I might as well use it. And when I factor this left side, or this trinomial here, I'm going to get x and plus and minus and 4 and 3. 4 minus 3 is the 1 in the middle, 1x. This is my numerator now, and it's over x minus 3, which is this x minus 3. The x minus 3's cancel, and I'm left with, you got it, x plus 4. That's my final answer. Okay, so I hope you're okay to follow along with that. I know it gets, your work will do the same thing as you're writing these out. It's like, you know, oh my God, where am I here? Always take a time out and reorganize your work. All right, next up. How many more we got here? How about 2 more? All right, here is number 9. And then we have number 10 to go, and that's our last one for this wonderful section. Okay, so this is the problem, and notice what's happening. 3 minus 7 over 4x minus 7. But what do we know we can do? Put it over 1. If I put it over 1, now it's coming back to me. I got to make the denominators to be the same. So if I want this to be 4x minus 7 over here, I've got to multiply it by 4x minus 7 times 1. And what I do to the bottom, again, I have to do to the top. 4x minus 7. All right, when I bring it over, I'm going to have 4x minus 7. And then let's figure out what our numerator is. I'm going to use the distributive property and multiply 3 times 4x, which is 12x. And 3 times negative 7 is negative 21. And then this is just simply minus 7. Okay. Now let's combine our like terms in that numerator. When I do, I'm going to have 12x minus 28. Negative 28, 21, negative 21 minus 7 is negative 28. And I know my denominator here is 4x minus 7. And what I want to do now is I want to factor the 12x minus 28. And when I do, it looks like I can take out a 4. Let's see, I'm going to do it over here. 12x minus 28. I think I'm going to suggest you do the same thing. Go to the little sidebar, if you will, and do your calculations over there, then bring it over. That way your paper won't get so messed up with numbers and letters, and it adds to confusion. So I'm going to suggest that we do that. Okay, so here I've got a common factor of 4 that can come out. And what's left over is 3x minus 7. That is my numerator now. And oh, how clever of them, whoever did this problem. So if this is my numerator now, factored, it's going to go here, 4 times 3x minus 7, and it's going to be over 4x minus 7. And here's an example I want to bring up again with you. You cannot cancel these 4's out. If you factor out the 4, you could, but 7 is not a multiple of 4 at all. So you can't factor that denominator at all. And you certainly can't cancel it because it's associated with this minus sign. This is a subtraction problem downstairs. We need factors to be able to do that. Okay, so in other words, this is my final answer. I got to leave it alone. Okay, that's that. And we got one more with practice problem 10. Okay, here it is. Number 10. It's saying, write an expression for the difference of twice a number and its reciprocal. Then simplify. So we want to write an expression for the difference of twice a number and its reciprocal. So we start with a number. Here's my cool way of doing it. A number is x. Twice a number, so I'm going to write that as 2x, and its reciprocal. So I need the difference of twice a number. Here's my difference of twice a number and its reciprocal. So what's the reciprocal of 2x? What's the reciprocal of 2x? Twice a number and its reciprocal. It's going to be 1 over 2x. Okay, so that's my problem. And if this is my problem and I'm subtracting these two terms, I've got to get the denominators to be the same. So remember, this is over 1. And I've got to make both denominators 2x. So I'm going to multiply the 1 times 2x, top and bottom. Okay, let's see what we've got. I've got a denominator of 2x, and then my numerator looks like it's going to be 4x squared minus 1. This looks like a difference of 2 squares, but will that help me at all? Will that help at all? Twice a number and its reciprocal. Okay, if I factor 4x squared minus 1 and I get 2x minus 1 times 2x plus 1, is that going to help me with my canceling? It is not going to help. This would be my final answer. That's it. Okay, well, that was easy enough. I have you may find that as well. If you look on your answer block, if they give it to you in your book, page 443, their answer is 2x squared minus 1 over x. And I think that may be because of the interpretation of twice a number. Write an expression for the difference of twice a number and its reciprocal. So twice a number is 2x, its reciprocal is 1 over 2x, and that's how I'm determining that. They may be going by an x, or they made a mistake in their answer. I am very confident this is my answer, and I stand by it. Okay? How do you interpret twice a number and its reciprocal? Okay. All right, that's it for now. Thank you, and talk to you again soon for the next section of 5.4.